Hey folks, today we will talk about the personal knowledge graphs and time. And it's a lot of discussions if time is really exist. And but time is for sure important. And that we have the regular knowledge graphs, and they are quite static. So you have the facts and the connections between the facts, but it's not how we have it on our daily life, because sometimes your memory change over the time. So how to bring the time to the concept of the personal knowledge graphs and knowledge graphs in general? And here we have the two big groups actually, that temporal aware graphs and the dynamic graphs. And it's a big difference between them, because in temporal aware graph they not just encode time, but they keep the structure of the graph static, but they maybe change some parameters or attributes in a graph over the time, and it's easier way. And it's quite common for the logistic networks, for example, that you have roads that not changing, but the traffic actually are. Dynamic graphs is most complex type of graphs, because it's mean that graph evolve over the time, and it could change their structure completely. So how to model this stuff, because it's quite complex, and how to represent such things. So the most straightforward way that you could have in your head, it's just a snapshot of the graph. So every time, for every timestamp, you have just a snapshot of the graph over the time. It's work well because it's quite simple, but we have a challenge that even with the structural sharing, it could be extremely expensive space-wise. So it's not the case if you want to keep something small, and it's not the case when you have a lot of time points. So the next strategy actually is to keep the history of the ages. If your node's not changing so often and you just change the connection, you just keep the track of the ages. It's yet another thing, and it's quite simple, and it's simple to implement, but it have a lot of limitations. The most straightforward way for sure is just extend our triple to quintuple and add two extra parameter like start and end date, and make nodes and ages to have a lifetime. And it's most straightforward, persisting, easy way, because then you just know that you have no deletion operation. Let's say you just have the end of lifetime, and actually it could be much easier. And but it's have a lot of limitations and logical questions. What's to do with nodes that doesn't have the end, or maybe they always there, and all other things, but it's easy to model. And with the quintuples and all other things, you could even have the modified RDF that allows you to do it. So it's quite a good one. I like this approach. Another approach that used mainly in this graph neural networks and dynamic graphs, that you don't have the graph at all. You don't have the graph at all. Instead, you have the streaming of the graphs, and when you do the streaming to the machine learning model, you not stream the graph, you stream the operations. So you reconstruct the graph from the operations all the time. And actually, it's quite popular in many graph machine learning models that we use nowadays, but it's quite complex, and it's similar to the event sourcing actually that we quite often use in our architectures. And the last and most philosophical thing, that maybe time is not timestamp, maybe time in distributed systems doesn't exist as we used to be, and instead of timestamp we could use the order or partially ordered events. And in this case, time will be just magical hybrid clock combination of the date and integer, or maybe integer itself, that will represent when this event appear. But this topic, it's a separate topic for the separate video, how to represent the time in a distributed system and distributed knowledge graphs. So thank you for listening. I was from Copenhagen this time, and see you next week in Berlin. Tschüss.